So I'm here for the next 45 minutes to talk to you about blue skies and puffy clouds. And this feels a little bit overcompensated. In particular, I want to talk about the blue skies and puffy clouds that you see in this picture here, which I took a few years ago in a small plane flying over Central Florida mid-afternoon. And this is kind of a metaphor for cloud migrations in my mind. Because there's a few things that you kind of know about pictures like this. If you've been in Central Florida in the middle of the afternoon, you know that that's when the thunderstorms build. So these clouds are nice and puffy, but they've got teeth. If you've been in an airliner going through storm clouds, you know it's a bumpy ride. I can assure you it's bumpier in a small plane. The thing that you might not know unless you're a pilot, I tripped over it again. The horizon line is right about here. And if there's something between you and the horizon, you're going to go right through it, which is an important safety tip if it's a mountain. Okay, so you've probably seen a slide that looks a lot like this. This is the promise of the cloud. You have a knob that you can turn to get whatever level of resources you need, and you pay for them only what you need when you need it. And out the other end, you get happiness and profits. The reality, when you sign up for an Amazon account, is you see something like this. And really, you don't see this anymore. This is about 3 months old. What you see now, because there are so many Amazon services, is a search bar and a link to tutorials. It can be really daunting. So the point of this talk, for the next 43 minutes, is to dive in what I think of as the key points if you're deploying into the clouds. And it's very much an intro-level talk, although I'm happy to ask questions afterwards, or answer questions. So the first thing, as always, preparation, okay? And there are a lot of good reasons for moving to the cloud. The first reason, which is kind of the standard one, is the infinite scalability. And I once worked for a company that did this exceptionally well. They were primarily in a data center. They had their data centers perfectly designed for their normal load. However, they knew that there would be a few days every year when their load would double, triple, quadruple. So they set up, they were early adopters of EC2, pushed out the loads into the EC2 instances for those days, shut it down afterwards, only had to pay for what they needed. And that, again, is the promise. Number two, I come from development, and I love the idea that I can spin up an environment for my development work that mimics production. Or I can spin up an environment for testing. At one company where I was building a distributed system, we might spin up 12 instances for a couple of hours to run our tests and shut them down again. And if we needed to run the tests with a different set of configurations, spin up 12 new instances. Very useful. Similarly, replicated environments for production. And I've spent far too many midnights sitting, waiting for deployments to complete on the one production machine. With the cloud, you don't do that. You spin up a completely new machine or fleet of machines for production sometime during the day, verify that they work, and then slowly migrate your traffic over. No more late nights. Deploying your applications in your user's geographic region is a really good solution. And number one, you improve latency when you do that. Number two, certain political entities, such as the EU, really want their citizens' data to be in data centers on their soil. So if you're in that situation, Amazon and other clouds are worldwide. And lastly, of good reasons, using managed services. Don't spin up active MQ brokers. Use a cloud-provided queue broker. You get rid of that maintenance overhead in addition to the cost of the machines. Something that's not good is people think that you can reduce or eliminate operations staff, and you really can't do that. I'm a developer, and I'm going to be the first person to say developers are not good at operations. If you don't believe me, go to Stack Overflow and look at all the people who write in, I've deleted my SSH directory, and now I can't access my instance. What do I do? And you feel sorry for them, but oh well. That said, something really, really important. If you are an operations person and come from a data center background, the cloud is a completely different mindset. A lot of the things that you already know that you practice, what a former boss of mine referred to as the illities, scalability, manageability, he had a half dozen of them. That's a good thing. actually thinking that the cloud is just like your data center is bad for both small and large reasons. On the one hand, it's a completely different environment. I have known network engineers who will spend hours carefully plotting out their network segments so that traffic for one application stays on a single segment. When you move to AWS, you have no idea where your traffic is going. You have no idea how many hops connect your machines. But it's really fast. You shouldn't care. Whoops. On the other side, you may have heard of the cattle versus pets metaphor. And if you haven't, the idea is that machines and data centers are pets. You care for them. You stay up with them when they're sick. You continually patch them. I don't know, I haven't patched any pets yet. Versus machines in the cloud are cattle. You turn them out on the range in the springtime, you round them up in the fall. With luck, you get most of them back. It's a good metaphor, but I prefer what I call the pets versus plushies metaphor. Okay? And this is a warehouse for plushies. And the key is they're all the same. You go into this pile, grab a Minnie Mouse, grab a Winnie the Pooh. They're all going to be the same. If you're 4 years old and leave Winnie the Pooh on a beach like I did, you're going to be sad for a little bit, but then your parents are going to go to the store and get another one. And kind of the key story I have for this is a few years ago I was out with a friend on a motorcycle ride, and we were somewhere out in central Pennsylvania. He's a network operations engineer. His pager went off. We pulled over the side of the road. He tethered his laptop to his phone, typed for about 2 minutes. Boom, closed it up, said, let's go. At lunch, I said, well, must not have been a big problem. He said, oh no, our main database server crapped out. I said, and you were able to fix that in 2 minutes. I'm impressed. He goes, no, I took it offline, swapped in a new one. And that's kind of the key insight for me of the pets versus plushies, is just swap in a new one. Okay, if you're migrating, 2 basic strategies. Strategy number 1 is lift and shift, where, subject to the caveats of differences between the cloud and your data center, you think of the cloud as your data center. You spin up EC2 instances and deploy your software in there. So, if you're comfortable deploying Postgres on bare metal or on a virtual machine in your data center, by all means, you want to do it in the cloud. And then over time, you can transition to where you use more cloud-native services. The other approach is cloud-native. And the idea is that you are running completely in the cloud, leveraging the managed services as best you can. And this works really well for greenfield projects in large organizations or for startups. In fact, the cloud has made a number of the companies I've worked for possible because they're startups. Okay, so that's kind of preparation. So next, the terminologies that you need to know. And there's basically 3 areas that we're going to look at. The first, and in my opinion, most important, is identity and access management. And this is how Amazon, and we're shifting into Amazon from general cloud deployments now, this is how Amazon controls access to resources. Resources being things like S3 buckets or DynamoDB tables. And it starts with users and groups. And users and groups in Amazon are just like users and groups everywhere else, right? A user is able to log into the system or consume resources. You can attach privileges to users. You can attach privileges to groups and have the users be part of the groups. For example, at my current company, we have a sandbox environment where the developers group, if you're a member of that group, you basically have full access to do everything. In the operations environment, we also have a developers group, but the only thing you can do is access our Elastic Container Registry for Docker images. So it's a nice way to have groups of people. You can delegate users in AWS to services such as Active Directory. I've seen it happen. Everybody that I've talked to about it kind of complains about it. So most of the places I've seen, it's so easy to maintain a separate user list, they just do it. I'd be interested to hear other experiences. Okay, at the bottom here I say users and groups can be assigned policies. And policies are, at the most basic level, how you control access to resources. I like to think of policies as capabilities, okay? So for example, one policy that I like to create is a monitoring policy. And that gives the capability of writing CloudWatch metrics, of writing CloudWatch logs. And in some cases of writing messages to SNS, Simple Notification Service topic, which go out to the cell phones of all your developers. So that's a capability. Policies can be very broad. They can grant you complete access to create or delete S3 buckets or access the files in any of the buckets. They can be incredibly narrow. For one recent project, we created policies that allowed you to upload a file to a single location in a single S3 bucket. You couldn't download that file afterwards. You couldn't see that file afterwards. You were just allowed to upload it. If you wanted to be even more granular, you could put a control in that says only allow uploads from these 3 IP addresses. Most people, as I said, tend to do fairly broad policies, but I think it makes sense to tie them to the capabilities that your application needs. Clicking a little bit fast. Roles are kind of the step up, an aggregation of policies. And roles are really the secret sauce of Amazon, of AWS, because you can assign roles to compute resources. So you can create a role that has all the policies needed for your application and assign it to the EC2 instance or ECS container where your application is running. That means that you don't have to distribute real credentials to those machines. It also means that you don't have to worry about having someone capture those credentials and have access to the resources, or rotating the credentials as a general security procedure. The other thing that roles are really good for is users can assume them. So, for example, especially in a small company, developers will have their environment where they're constantly creating and deleting things, taking down EC2 instances. But again, small company developers also do production support. I don't want the ability to shut down our main database, except when I have to. And you can encapsulate the ability to do destructive acts, such as shutting down databases, into a role. And then you assume the role to do the destructive act and relinquish the role immediately afterwards. Roles are also the way that you do cross-account permissions, so that users in one account can assume a role belonging to another account. And that brings me to accounts and organizations. So an account is kind of the permissions boundary of AWS, and it's a semi-permeable boundary. You can grant permissions across accounts, but many of you probably already have AWS accounts. You can't see or access the buckets in my AWS account unless I grant you that access. So a best practice here is you use accounts to create separate environments. You have a developer's account or sandbox account. You have a QA account. You have a staging account. You have a production account. You don't have to worry about deployments into one account being able to accidentally damage resources in another. For small companies, managing individual accounts, fairly easy. Larger companies, enterprise scale, Amazon introduced organizations a few years ago. And the idea of organizations is it's basically a hierarchy of accounts. So IT can own the organization, the root level account, delegate responsibility to different groups within the company to create their own accounts, which they can then self-manage. Organizations is also a way to roll up billing statistics, to keep track of your costs, to cause heart attacks to your accountants. Okay, summary here, primarily for people looking at the slides later. I'll have those on each section. Moving along to the network, which for me, I look at AWS as being everything is built on EC2 for compute, S3 for storage, and a really, really smart network. And networks start physically at the region. Okay, and a region is a geographic collection of data centers all over the world. This picture is from about 6 months ago. Those green circles have pretty much been filled in to be real regions. The gold circles are the actual regions with a number of availability zones, which we'll talk next. Regions, a lot of resources are namespaced by regions, which can simplify your configuration. So you have a My Application queue, for example, can be in US East 1, US East 2, so on and so forth. You can configure basically clones across region, which can be really useful, again, to be close to your customers. Important note about regions is that not all services are available in all regions. Okay? Amazon typically rolls out new services to the US East 1 region, and then over the next few months starts pushing them out to other regions. So if you're using bleeding edge services, and even some that have been around for quite a while, you might be forced into using them in a particular region. Within regions, you have availability zones. And Amazon doesn't talk a lot about exactly what an AZ is. Most people just think of it as a data center, although it's probably a cluster of data centers. A few years ago, a reporter for either Wired or Fast Company drove around Ashburn, Virginia to try and figure out where all the Amazon data centers were. Amazon doesn't let you know that. So availability zones are the unit of high availability. Okay? The idea is that each AZ is physically separated, separate power, separate network. If you deploy your application into multiple AZs and a backhoe cuts through the main fiber bundle going into one of them, you're still up and running. Availability zones are not a unit of disaster recovery. First off, because there have been times when the entire region has gone out. And in fact, recently we had the experience of most of S3 going out. For disaster recovery, you need to go up to the region level. And for true disaster recovery, you need to get outside of Amazon. Okay? I know of at least one company that made the mistake of not being very careful with their root access keys, and someone got in and deleted every backup they had because they didn't store anything out of Amazon, and overnight shut down the company. So moving things, if you want normal levels of disaster recovery and you have good security, moving to different regions will work. Moving off-site, but beware that if you have a terabyte scale database, even if you have a fast connection, it might take a day to copy a full backup of that database. All right, so those are the two physical divisions of the AWS network. Now let's get into kind of the logical divisions. And again, the AWS network is completely software defined. However they have switches and wires arranged is immaterial. So the virtual private cloud logically is a lot like the network in your data center. It's isolated from the internet except when you make connections, and you have complete control over how things are organized within it. You can have a small number of virtual private clouds per region, per account. In the past, VPCs have been used for basically isolating production and development environment, but accounts are a better approach. Inside the VPC, you have subnets, which are logical network segments. And again, you can get very particular with how you configure your subnets. My personal belief, having been burned by running out of IP addresses in a subnet one time too many, is to make them as large as possible. The real division that you care about is public versus private, okay? And there's a specific definition, but in general, nodes on a public subnet can, but are not required to have a public IP address. Nodes on a private subnet can't. You cannot access a private subnet, inbound access, without going through a public subnet. And also, you can't get out from a public subnet. So if you're running a yum update on a machine in a private subnet, it's going to fail unless you create a NAT, a network address translation, between that subnet and the outside world. And there are multiple types of NATs. So you can control the routing of traffic between subnets, so you can get very artistic with how you do things. I think a simple approach of your private subnets route traffic into your public NAT and your public subnets route to the internet is sufficient for 90%, maybe 99% of cases. So here's kind of putting it into a picture. You have your VPC, which is the whole thing, And I've put two availability zones, number 1 and number 2, and a public and private subnet for each. The question of how many availability zones you need is kind of an interesting one. If you're basically just looking for redundancy, 2 should be enough. It's unlikely you're going to lose more than 1 unless you lose a whole region. If you're doing something that requires a quorum, such as running a zookeeper cluster, you're going to need 3. You probably don't need more than that, although I'm sure that people have cases where they do. We'll fill this diagram in a little bit upcoming. The last thing to know about networking in Amazon are security groups. And security groups are basically the Amazon firewall, Amazon replacement for a firewall, with one key difference. They run in the network fabric. Okay, so like if you're familiar with IP tables to set up firewall rules on individual machines, you can do that, but the IP tables rules apply after the security group rules. And like any firewall, you're basically saying, accept traffic from these addresses, send it to this port. One thing that security groups have that's really, really nice is you could say accept traffic from any machine that's been assigned this other security group. So for example, kind of a traditional load balancer, app server, database approach. You can create a security group for the load balancer that allows traffic from anywhere on the internet for ports 80 and 443. On the app server, you can create a security group that only allows traffic coming from the ELB security group. So now you have automatically locked down your app server to traffic from your ELB. Similarly, your database can be configured with a security group that only allows traffic from the app server security group. Very nice way to lock things down. So one other thing that you'll see is network ACLs, and I'm going to jump over them. I have seen some very creative use of network ACLs. I can't say that I've seen any good uses, but then I'm not an operations engineer. I think in 99% of the cases, security groups will do everything you need. Other stuff, again, is if you look at the slides later, there's a link at the end. Let's dive into deployment. And this is very much the last thing that you should really think about when you're planning to migrate to the cloud. Far more important is security and networking. Get that architecture right. So deployment, you have a continuum for almost every Amazon service. And the idea is that on one side of the continuum, you have fully managed services. On the other side, you have self-managed, okay, where you're responsible for maintenance versus Amazon is responsible for maintenance. On the self-managed side, you have a lot of knobs you can twist to tune things to your specific needs. On the fully managed side, you have a few knobs generally to twist, but Amazon basically sets it up to do the right thing in almost all cases. So here's kind of the archetypal network diagram, and I'm going to start on the right side, inside the VPC. And generally, you'll use an elastic load balancer to accept traffic from the internet and send it on to your compute resources. Okay, elastic load balancers are basically like HA proxy or any other front-end proxy. You can use them to terminate SSL, for example, and so that everything comes in on 443 and then gets sent to your compute nodes on 80. You may or may not be comfortable with that. Personally, I am, but you may live in a world where you have to have encryption all the way through. The compute nodes, I'm leaving vague. I'm going to talk about them in another slide. But one key thing to note is that they're scalable. And again, the promise of the cloud is scalability. If you have a lot of traffic on your website, increase the number of compute nodes. The compute nodes are split between private subnets and different AZs. You also have a database. And I'm showing a fairly traditional database, which is a master replica database. Let's say a Postgres database with replication. And the idea is that all write accesses go to your master. I don't show read accesses to the replica, but you can do that. And if the AZ goes down, then you switch over to the replica. And there's more or less pain involved in doing that. Outside of the VPC, and this is kind of This is still within the Amazon fabric, but it's not tied to your VPC. CloudFront is a content delivery network. And the idea is that it has caches in individual cities. I think there are 100 some odd cities around the globe where your static content, things like your images or JavaScript or CSS, gets cached. So the round trip time, your people in London don't have to go across the ocean to Virginia to pull this data in. Very useful. You do pay for it. S3 is where you store those static assets. S3 is a simple storage service. Fairly useful for all sorts of storage, but in this archetypal scenario, it's just static assets. And in the front is the web application firewall. And the web application firewall, it provides DDoS protection. It provides various rules, such as you can specify how long your query strings are allowed to be. You can say that if I get more than 10 requests to my login form from one IP address within a minute, shut that down for a certain amount of time. And you could also use it, a nice use of the web application firewall is for whitelisting. If you have specific clients of your APIs, you could put their IP addresses into the web application firewall and block all other traffic. And that gives you can have up to, I think, 10,000 IP addresses in each firewall rule, versus trying to use security groups to block this traffic where you're limited how many addresses you can put in. And the key thing here is you can trim this down as much as you want. As I said, this is an archetypal deployment. You don't need CloudFront. You really, if you're daring, you don't need the web application firewall. You could just expose your ELB to the open internet, and a lot of people do this. You could replace the ELB with HA proxy. If you're really daring, you could just put your compute nodes exposed to the internet and use a DNS round robin to send traffic to them. I really don't recommend that. So we've talked about the web app front end, and I said I skipped over the compute nodes because this is really a very good illustration of the continuum for Amazon. On the one hand, you have EC2, the Elastic Compute Cloud, which is a virtual machine running in the cloud. You pick how much CPU capability you want, how much memory you want, you give it however much disk you want, and you are responsible for managing it. When you bring it up, it comes up with an operating system. You need Apache? Install it. You need to have Java? Install it. And over time, if you keep these things up, you have to continually patch it, right? You're going to have operating system updates. They don't get applied automatically. Moving into the middle of the continuum are containers. And Amazon has a couple of solutions for containers, basically Docker images, where you're packaging up your application with the frameworks that it needs. So if you have a Java web server, you might base that on a Tomcat Docker container. And you just deploy to compute resources. And depending on how you want to configure it, you can either configure your own clusters of machines to run it, or at Fargate, you can just say, I need a compute resource with 4 gigs of RAM and 16 CPUs. And ECS, I'm assuming EKS as well, I haven't used it, ECS will just spin up the machine to run your container. And on the far managed side, you have Lambda. And Lambda, you just write your code. And you have a lot of different languages. You can use Java, you can use JavaScript, Go, and you deploy your code to the Lambda as a Lambda function, and then it gets invoked automatically. And AWS will spin up the machines. It's actually running within a container. AWS will spin up the machines to run however many are necessary to meet your load. Okay? So if you get one request coming in an hour, it'll probably be starting up and shutting down every time you get the request. If you get 10,000 requests in 1 hour, it might spin up a dozen, 2 dozen, 100 instances to handle those requests. Key point though, again, you have a lot of control on the one end. On the other end, you have very few knobs to turn. And it's very scalable, but one thing I've found is that for the first request, you are paying for startup time. And especially if you're running something in the JVM, you're paying a lot for startup time. It might take 15 seconds to do the first request. After that, 100 milliseconds to process a request, really fast. So that's compute resources. Databases are on a similar continuum. I don't show EC2 and self-managed Postgres here, but if you're comfortable installing and managing your own database, you can do that. You can pick an EC2 instance, and you can tailor that instance and tailor the features that the database supports. Somewhat more managed is a relational database service, and Amazon offers, I think, a half dozen different database engines for RDS. And basically, under the covers, it's spinning up an EC2 instance and installing software on it. Okay? You tell it how much memory, how many cores, how much disk space, and it figures it out. You do have a lot fewer knobs. One of the most important is super user access. In fact, been dealing with that recently. Is a lot of people use a super user account to set up their database and sometimes work with their database. You don't have the ability. So, if you've set up table ownership, you can't just log in as super user to suddenly say, all right, change this table schema. That could be a pain. Similarly, you can't install, in Postgres, you can't install any C language extensions other than a limited set. Aurora is a type of RDS installation, but it changes the back end, the way storage is handled. And it's kind of cool. Werner Vogels wrote a nice little article kind of diving into it. It basically separates out your disk storage from your transaction log. Most nodes in the cluster just deal with the transaction log, and it is offers very quick failover in case of problems. The knobs that you change, you don't actually have disk space, you pay by I/O. So you have to kind of figure out what your usage is and adjust the size. You might need to increase the size of your Aurora instance type to have more RAM so that you're caching more data. And finally, on the far end is DynamoDB. And if your application uses a relational database, DynamoDB is not an option. It doesn't do joins. It doesn't really do queries very well. On the other hand, if you're pulling data and updating data from a primary key, such as a user ID, and everything hangs off that, Dynamo can be very useful. It's distributed, has redundancy built in, so there is no failover, and you basically pay for how much capacity you need. Last thing I want to talk about is configuration management. You may have a good approach to configuration management. A lot of the companies that I've worked with don't. Generally, the best is you create some environment variables somewhere in Etsy and load those up. Again, you don't really want to be pushing environment variables. You don't want to be pushing credentials onto machines, because if the machine gets breached, those credentials are available and can be taken away. So Amazon offers a service for storing your configuration data, which I think is a really nice approach. It's basically hierarchical name-value pairs, can store things encrypted, and integrates with Secrets Manager, which is a tool for maintaining things like database credentials that's closely tied to RDS, so it will rotate credentials on a regular basis. And one of the things I really want to get across by this page is just how interrelated all of the Amazon services are, right? So your application can read from parameter store, getting your database passwords that are automatically rotated once a month, interacting between the Secrets Manager and your RDS instance, which is a lot of stuff that you don't have to do as an ops person. So general advice, and I'm actually going to go through this one. If you're just starting out, Elastic Beanstalk is a pretty good way to start. And Elastic Beanstalk, basically, if you're using a deployment that's standard, like a JEE app server or Node.js server, Rails app, it lets you specify your deployment bundle, how many EC2 instances you want, the configuration of an elastic load balancer, and auto-scaling, all in not one step, but a very small number of steps. You may or may not outgrow that. If you do outgrow that and move to where you're really wanting to control your deployments using something like Terraform or CloudFormation, the best practice is to pre-build your AMIs, the Amazon Machine Images. Like I said, when you bring up an EC2 instance, you get an operating system. You have to install anything on it that you need. It takes a long time to install software. So you can use a tool such as Packer to pre-build, pre-install all of the software you need on the Amazon Machine Image, and then just stamp out instances. Saves a lot of time, turns a 5 or 10 minute startup into 30 seconds. And lastly, to channel Ron Popeil, set it and forget it. Okay? One of the practices that I can't quite accept, but then I'm a developer, is that you don't allow any SSH access to your production machines. As in, you bring up the machine without an SSH access key enabled, okay? Nothing is allowed to change the configuration of that machine. And if you follow that approach, then you don't have to worry about configuration drift. You don't have to worry that someone has gone in and made a little tweak to the database and then forgotten to update the standard database configuration. Again, with my friend with his main production database, you just send it out there, and if there's a problem, you replace it. Patches. You should never patch your EC2 instances. You should just create a new AMI and do a rolling deploy onto new AMIs. And you do that every week, every day. Last company I was at, we spun up and spun down our main web server from 1 machine running overnight to 8 machines running during the day and killed the oldest one. So we were always getting a machine that's no longer than 2 days old. All right, so again, this has been kind of a whirlwind tour. And that brings me to my final thought. I want to take you back to that small airplane over Central Florida as the thunderstorms are brewing. Whoops, oh, that was a bad seg. So this is helpful advice if you have a friend with a pilot's license who offers to take you for a ride. Make sure it's a clear day. Now, as it turns out, I have a pilot's license and I'm not instrument rated. On the other hand, the person flying the plane was my brother, who's a professional pilot with thousands of hours of experience. So we were going to head through the clouds, we were going to get bumped around. I didn't worry about coming out the other end. And I think with cloud migrations, as with flying through clouds, there's really no substitute for experience. Okay? Having a person who knows all the little ins and outs of whatever your deployment platform is, who has done it before. Otherwise, you kind of adopt the approach of the non-instrument rated pilot who lives, but does it by zigzagging around the cloud tops, sometimes going in the completely wrong direction, and all the while hoping that your destination remains clear. So, I'll leave that up if you want to take a picture. The slides are up on my website. And if you've gone to the Slido, I have to bring that up on my phone because I don't connect to conference networks. I may be paranoid. So sorry, it will take a minute. We are in Salon D. Can you track when users assume roles? Yes. So Amazon has a lot of mechanisms for tracking activity. CloudTrail will keep track of major system events such as bringing machines up or down. I think CloudTrail also, and this is where I'm only an associate solution architect. I think CloudTrail also tracks role assumptions. You might have to explicitly enable that. Could I share the presentation? Yep, right there. How do we do capacity planning and cost calculations for lift and shift? Do we have any tools all ready to support out of the box? That's a tough one. And here's why it's tough. is you would think that if you're doing lift and shift, you already know the capacity of the machines that you're currently using. So you just pick a machine that's the same size, and you can get the pricing off of Amazon's website, just set up an Excel spreadsheet. The trouble is that, number one, there are a lot of factors that go into cost calculations with Amazon, and number two, the hardware really isn't the same. So you may think, hey, I'm running 8 processors, 32 gig of RAM with an attached SSD. I can do that in Amazon. But in my experience, the performance is slightly different. I have a post on my website about comparing build times on Amazon versus on a dedicated PC. And the Amazon build times, even with an attached SSD, are slower. So there are companies that exist to do capacity planning. I'm not familiar, unfortunately, with what they offer. And I do know that some of them go out of business rather quickly. Does AWS have Delta restoration on RDS apart from backup snapshots? So Aurora allows you to do point-in-time restoration going back through your snapshot range. So you can pick any point in time. Basic RDS, I think, is just a daily backup, but I would have to look to be sure. And I think that that is the last question. So, thank you very much.